Okay, so there's an interesting formula that says 1 squared plus 2 squared plus 3 squared plus all the way up to n squared is n times n plus 1 times 2n plus 1 all over 6. Now that, like, where does that come from? That's what we'll learn how to prove formulas like that later on in algebra and calculus. But let's check a few. Let's just check if we just add up 1 squared. What should we get?
Well, you get 1.
Okay, so does 1 equal 1 times 2 times
5. The 3.
3 all over 6?
So 6 over 6, which is indeed 1.
Okay, now let's check it for 3 just for fun. Okay, so I have 3 terms, so what should this add up to?
So it should add up to 3. Well, it should add up to 1 plus 4 plus 9.
Which is what?
Which is, it's 14.
Okay, so let's check our formula. Does 14 equal, what's n in this case?
3.
3.
3 plus
3 times
3 times
3 plus 1,
So
which is
4.
4.
So, and then 7 times 7.
7
All over 6.
all over 6. Does 14 equal?
Well, so you can cancel the 6
Okay,
with the
zoom
3
out
and the
just a little
4.
bit. The 6 cancels with the 3 and the 4 to leave
We have 2 times
2,
7.
which is
14.
14. That's
Yeah.
interesting. So now with this formula, if you assume it's true, if you believe me, like we could add up the first 10 squares really easily. It'd be 10 times 11 times 21
All
all over 6. Okay, so the 6 is going to cancel, the 3 is going to cancel there, leaving a 7, and a 2 is going to cancel here, leaving a 5. So we get 35 times 11, which is 350 plus 35.
To 385.
385. So the first 10 squares add up to be 385. Well, that's pretty neat, but I still don't see a third anywhere.
Maybe we need 1 cubed plus 2 cubed plus 3 cubed.
Well, but we said we were adding up squares, right?
Yeah.
Okay. What happens to this formula when n gets really large? What do you think?
It becomes more and more 2n plus 1 over 6.
Well,
Why is that?
The result would get bigger.
Well, actually, it's more n times 2n, because the 1 matters less and less.
Okay, so as you get bigger and bigger, you're right that this 2n is the biggest term, but this is still pretty big. It's n, and this looks like n. So as n gets large, this starts to look like n times 2n all over 6.
Which is...
Wait, let your brother say it. What is n times 2n over 6?
Well, it's n squared times, it's n squared times 2n.
Which is what?
Which is 2n squared.
Well, it's n squared times 2n.
Well, that would be 4n squared.
N squared times 2n all over 6. So what happens here?
Well, you have to you can multiply this out.
Okay, well, what does that multiply out to be?
Well, if you're you have to multiply by, you could say it's n cubed times 2.
Ah, there you go. N cubed times 2 divided by 6. And how does that simplify?
Well, you could use n cubed over 3.
N cubed
And now we see
over 3. And now you also see what?
Oh, if n is
A cube. You see the cube divided by 3.
cool.
How about that? So what did we do? We added up a bunch of squares, and it started looking more and more like the cube divided by 3. Which is what?
Which is the slices.
Which is exactly what we saw, right?
Yeah.
So isn't that amazing? There's an incredible connection to algebra here. There's a neat way to see this with Zoom Tool, and it's a really cool 3D printing exercise.
Yeah.
Isn't that neat?
Yep.
Yeah.
All right, another fun James Tanton tweet.